Hi, everybody. Welcome to Science with Marty.
Woohoo!
I'm Corey.
I'm Marty.
And this is going to be science.
Yeah, we're going to talk about science. Good idea. So we're going to talk a little about climate and weather. And so sometimes there's a confusion between climate and weather. And so climate is what is happening over the course of a long period of time, like over a year or a number of years. So we're in a moderate climate. It's not like freezing all the time, or it's not like hot all the time. But weather is what's happening right now. And you can see it's a little breezy here on the island. and so that would be the weather, okay?
But if it was always breezy, we could talk about that being part of the climate.
Right.
That makes sense.
And we're going to take a look at our first. Hello, everyone. Thank you for all the hellos.
Hi,
Nice
Nancy.
to see you.
Hi, Evan. Hi, April. Hi, Ryan. Hi, Tarini. As always, if you guys have any questions, you can put them in the Q&A box at the bottom of the screen. Hi, Paige. The raise hand feature doesn't really work, but if you want to ask a question or share something, just type that into the Q&A box and then we'll be able to see it. Hi, Letica. Hi, Gloria. Hi, Leia and Cian. Hi, Brando. Hi, Jackson.
And we're out of time.
Oh, that was awesome.
Okay, so the first thing I want to mention to you is tropical. You might have heard tropical storm. There's a tropical storm warning or whatever. So those are the tropics. The one up north that goes through Mexico and northern Africa, that is the Tropic of Cancer. And the one that goes through the lower part of South America and the lower part of Africa and Australia, that's the Tropic of Capricorn. And that space between those two red lines is called the tropics.
Now, to keep it really simple, I mean, when you hear the word cancer, the first thing you think of is like the disease, but cancer is also like a star sign.
Right.
Keeping it really, really simple, the Tropic of Cancer is called that. It has something to do with
right above
star
it
signs.
is the star sign of the Cancer. That's the crab, I believe.
So if you were standing on that line or like that part of the earth and you looked up, it's a certain arrangement with if you can see that constellation of stars or not.
Right.
And the bottom one, Capricorn, is another star constellation.
Right.
Okay. So when we say, I think when I was young and I first heard that term, Tropic of Cancer, I thought something like,
who would want to live there?
Yeah, that sounds terrible. It's really just an imaginary line on the globe that the line is marked there based on star constellations, but everything between these two red lines is tropical. That's where the warmer water, where the warmer days are. So yeah. Does that make sense to everybody? If you have any questions about that, just let us know.
Okay. Now we're going to talk about a cyclone. You might have heard the word cyclone before, and a cyclone is just a severe circular kind of a wind. So hurricanes and typhoons are all part of cyclones. Here is a map that tells you what they're called depending on where on the planet they're happening. Now, most of you might be familiar with the fact that hurricanes happen around the Gulf of Mexico and the east coast of the US, but there are also hurricanes on the other side, off of Mexico, going out into the ocean. And when that happens in Asia, it's called a typhoon. And of course, south of the border, it's called a cyclone, but they're all the same thing.
So just different terms for the same thing. The name is just different based on where it is on the globe.
That's what it is.
And these are all names in English, of course. I'm sure that in other countries, they probably have different words for it too.
That's right. Now, the main damage for any of these storms, any of these cyclones, is caused by storm surge. And we're going to take a look at a couple of pictures. There's the first one. So there would be, low tide, regular, and high tide. Mean doesn't mean angry. It means average. And so a storm surge could be a few feet above that. And so it could, if you're 10 feet above high tide and there's a 20-foot storm surge, you're underwater. Here's an example. Here's a picture of some storm surges. So you can see that this is not the normal way things are.
Ryan's asking, let's go over a little bit more of what a cyclone is.
It's just a strong circular wind. So a hurricane is a cyclone, and a what's the other one? Typhoon. Hurricanes, typhoons, And south of the equator, they're called cyclones, but they're all technically cyclones.
We have a picture a little bit later on, right? Let's just jump to that really quick.
We have this one. This
Okay.
is the one that's showing you north of the equator. You can see how that hurricane is spinning counterclockwise, or I could say the cyclone is spinning counterclockwise.
So there's a huge amount of air spinning and kind of like a giant tornado at sea, you could say, right?
Yeah, not a tornado, because tornadoes are narrow. These could be hundreds and hundreds of miles wide.
Well, this pattern looks like it's bigger than several U.S. states all put together.
Right. The biggest
bigger
one,
than
I think,
Texas.
is Sandy. Sandy was like 1,000 miles wide. And you can see how it's spinning in a counterclockwise direction. And if we look at the next one, the next picture, this is a cyclone, or you could call it a hurricane, I suppose, south of the border. And you can see how it's spinning in a clockwise direction. That's because of the
You can kind of see
rotation
that spiral there.
of the Earth.
Oh yeah, let's go back to that picture of the globe back here. So the Earth, when it's spinning, I'm trying to picture this in my mind right now. The sun rises in the east, seems to set in the west. So that means the Earth is spinning from left to right here.
From left to right, correct.
And I noticed that all of the white arrows are all pointing to the left.
Yes.
So I'm gonna guess, this is how science works, we make guesses and then we find out if they're right or not. that spin of the Earth has something to do with the path of these hurricanes.
It's called the Coriolis effect, which I haven't mentioned anywhere else, but as something is going up and the Earth is spinning below it, it gets this spin that you see there because it's spinning from left to right.
Yeah, we'd see the Earth moving from like left to right. So all the hurricanes are going from right to left.
Right.
So have we ever seen a hurricane kind of do the opposite, just go wild and go the other direction?
I'm glad you asked, and I have something that'll show you that in a little bit. As a matter of fact, it's the next slide that we haven't seen yet.
Keep on, I'll jump down.
That's up and down. And this one, look at this. Hurricanes can be unpredictable.
Wow.
So here's one, and you can see it started just north of the Dominican, in that area.
Okay.
And then it went out this way, and then it looped a couple of times. And so it's because,
that's wild.
Isn't that wild? And then it sort of died out at sea. But
it kind of went over the continental United States and then back out to the ocean again.
Right. So they're very unpredictable, and it's because there are a number of winds that would have an effect on it. So you mentioned, do hurricanes ever go the other way? Well, here's a perfect example of that happening.
Isaiah, if you just joined us, we're talking about large weather events today. We're talking about hurricanes right now. Ryan asks, how big is a cyclone?
Well, it depends.
You mentioned that there's some giant ones.
There's Hurricane Sandy, or Cyclone Sandy, they call it hurricane here.
Yeah.
Was 1,000 miles in diameter. You could have smaller ones that are 20 miles or 50 miles or 100 miles in diameter. As a matter of fact, I feel a bit of a breeze picking up. Do you feel a bit of a breeze? It
feels very breezy in here.
I think,
whoa!
Whoa! What's happening?
There's a hurricane happening right now. That's a lean into the wind.
All right. Well, luckily that was a short-lived hurricane.
That was a very brief one.
Yes, good thing. Let's take a look at our next picture because, hurricanes, I mentioned their path is uncertain. You might see a map like this. And what this map means is, okay, the red part is where the hurricane is, where the hurricane has been. And then, so scientists say, well, we guess based on that, it's going to go here. And they have this cone because they're not sure exactly where it's going to go. And then each color here has been updated from when it's down toward the bottom there. Scientists have updated their estimate of where that cone's going to be. Okay. And so you can see based on this cone. So when you see this cone of uncertainty, that's just where scientists think it's going to go because they don't really know for sure.
Because it's unpredictable. It can really turn and go any direction. So below this, I see like green layers. I see purple, brown. do the different colors mean anything?
It's
or are
just
they
at different times, the different guesstimates
okay.
that the scientists would make as to the path of the hurricane.
So they're using different colors just so that you see the difference between the layers.
Right.
Okay. So below this, I see like a purple layer. If I lived in South Carolina, for example, I might go, oh, it might be coming this way. But then they update it and it shows it going further to the left.
Right.
I'm like, oh, okay, we're probably going to be fine.
Right.
I'm going to check the Q&A box really quick. I think we have a few questions in there. Paige asks, what is more dangerous? If you're asking what is more dangerous between like a cyclone or a hurricane, I think what Marty's telling us is that they're all basically the same type of weather event.
Basically the same thing.
Yes. So they're probably not more or less dangerous than each other. They're all kind of dangerous.
They're all dangerous.
Yeah.
Now, in a few minutes, we're going to be talking about tornadoes.
Yeah.
And tornadoes are also very strong winds, but tornadoes are much narrower.
Okay.
As I said, a hurricane can be hundreds of miles or even 1,000 miles wide.
Yeah.
And could last for weeks.
Okay.
Tornadoes are relatively narrow, and they would last for minutes.
Yeah.
But a tornado is going to do a lot more damage if it hits you than a hurricane.
But more on tornadoes in a minute. Matthew asks, in the sea, can a cyclone have water in it?
Yes, they can. It's called a waterspout, and technically, it's not considered. Are we talking about hurricanes or
hurricanes? Right.
Oh, hurricanes. Yeah, hurricanes happen. That's where they grow. They grow in the warm, moist air, and so that they absorb, because it's hot air in the tropics. It absorbs a lot of energy. It absorbs a lot of water.
So hurricanes kind of made up of air and water at the same time. It's like a big churning mass of water and air.
Right.
So like when it hits land, we see a lot of wind, we see a lot of rain, because that's like the wind of the spiral.
Right.
But it's also the rain is like the water coming out of the hurricane.
Right. Because when it gets cooler, it deposits this moisture in the form of rain.
All that, it condenses, and it's like
a
lot of weather all at once.
Right.
Yes, Willow, it would, we hope so too. Gerard asks, are there land hurricanes, sea hurricanes, and fire hurricanes? I don't know about the last one, but I mean, hurricanes always start in the ocean, right?
They always start in the ocean. They need that moisture. They can't start over land because there's no moisture to speak of.
They can hit the land, and once they go over land, though, they kind of start to lose their oomph.
That's
right.
They can't absorb any more water, and any more. They actually give out the water, so they lose some of their power over land. Yes.
We'll just take a couple more questions here before we keep on going. Ethan asks, why does a hurricane start at all?
Well, you have these winds. You have these winds that have moisture in them, and it just starts spinning.
Like two currents just go past each other?
Yeah. And when they're warm and when they're full of moisture, they just start this swirling motion. You might have seen that, these little, they call them dust devils.
Yes.
Growing
up, I had a big dirt field behind our house. It was like acres and acres, and we'd get dust devils all the time.
Right. So that's the same kind of deal. You just get these winds that are going around each other, and then they start to absorb that moisture, and then you have a hurricane.
Okay.
Normal hurricane season is from the beginning of June to the end of November, and there's an average of a dozen hurricanes a year.
Wow.
Off of the U.S. coast. And it can cause a great deal. Look at that. And look, it even happens on the other side, west of Mexico, because it's still that warm moisture, and you get that warm moisture and you get some air spinning around, and you get yourself a hurricane.
So every one of these lines is a path that a hurricane took?
Right. It says here for a couple of years.
From 1851 in the Atlantic. So they've been keeping track of hurricanes in the Atlantic for a really long time.
For a really long time.
Data from 1949 in the Pacific. So whoever's keeping track of the hurricanes, they weren't keeping track until like after World War II.
Right.
And yeah, sure. AG, if you have any questions, put them in the Q&A box. The raising hand feature doesn't do anything. So go ahead and click the Q&A box. Yeah, so do the colors here? Let's see. I see that the red down at the bottom says it's a tropical cyclone, intensity below major hurricane.
Right.
And the yellow is a major hurricane.
Right, so there are different levels of hurricane, different categories, depending on the wind speed, actually. And so Category 1 is the weakest hurricane, and it's 74 to 95 miles an hour winds, and it's enough to cause minor damage to buildings. Category 2 is winds to 110 miles an hour, and it can damage houses. And Category 3 has winds to up to 130 miles an hour.
Wow.
That's twice as fast as you're allowed to go on most freeways. And so this can knock down electrical lines and damage buildings. Category 4 has winds to 156 miles an hour, and that can tear off roofs.
That's amazing.
It can tear off a roof. And then Hurricane Category 5 produce winds of over 157 miles an hour, and this destroys whatever is in its path. And our hurricanes can even produce tornadoes. The strong swirling winds can even produce tornadoes off of it. And we're going to jump right in. That nice segue. We're going to jump right into talk about tornadoes.
Okay.
So tornadoes form in the U.S. when warm, moist air, like from the Gulf of Mexico, has warm, moist air, and it comes up. And you have dry air coming down from Canada or over from the Rockies, and they start swirling together. And it makes thunderstorms, and that's where these hurricanes, these tornadoes are often produced. And there are, it says, tornadoes are one of nature's most destructive forces, and they come in all different shapes and sizes. So just as hurricanes had different categories, tornadoes also have different categories. And there are five types of tornadoes. And that's the first one. It's called a rope tornado because it looks like a rope.
This is like a rope going from the ground up to the sky.
Right, and this is how tornadoes, that's the smallest and most common type of tornado.
Okay.
And most tornadoes start and end as a rope tornado. And you can see why it's called a rope tornado. And you can see the spiraling going up into that cloud. So that cloud is moisture from the Gulf of Mexico. And then it's just hitting this other cooler air, and it's spinning, and it starts a spinning motion.
Awesome.
That's a rope tornado.
Some more questions here really quick.
Sure.
So Evan points out that tornadoes have a scale created by Theodore Fujita.
That's right.
He says it goes from F0 to F5.
You're way ahead of me.
That's awesome.
We're going to get there.
Katrina asks, does a hurricane have an eye like a typhoon? Well, I believe from what we were talking about earlier, so if a hurricane and a typhoon are the same thing, they're just kind of different words for the same thing, right?
Right.
So yes, they both have an eye in the middle. Do you want to talk about what the eye is of a hurrane? If we jump back for a second?
Well, it's just this center that everything is spinning around, and it's clear. It's not cloudy. It's clear weather, but not for long, because here comes that hurricane, and it's moving, and soon you'll be out of the eye into the full force of the hurricane.
So the eye is just the middle section where there is no swirling weather at the moment.
Right. Right.
Great.
And I think there's also an eye in a tornado. No, I've never actually been in a tornado. I've been in hurricanes. But I watched...
It'd probably be much smaller, the eye of a tornado.
Much smaller eye. But I watched Twister last night to prepare myself.
It's a great movie.
It's a great movie.
Yeah,
and you see at one point the inside of the tornado, which is pretty neat.
Cool.
Okay.
Just a couple more questions here.
Sure.
You guys are asking a lot of great questions today. Gerard wants to know, can a land tornado turn into a hurricane if it goes out to sea? I think it's too small, right?
It can turn into a water spout.
Which we'll cover in a little bit.
which we'll cover in a little bit.
Okay, but
But
it's too
not a-
small to be a hurricane.
Right, a hurricane can make a tornado, but a tornado can't make a hurricane.
Amanda asks, do they have gases in them? Well, a hurricane's mostly full of moisture and air. So
Air is a gas.
air is a gas, yeah.
And when there's moisture in the air, that's water that's in the gas form.
Yeah. Let's see. Isaiah wants to know, have hurricanes ever formed on land without any water? Well, no, I feel like by definition, they are formed out at sea.
Right.
If they're over land, there just isn't enough moisture for them to
That's
form,
right.
right?
That's right.
Okay. We'll take a couple more questions here before we move on, just so we don't get too far behind in all these awesome questions. Gerard says that there are fire hurricanes, and they're very rare and harsh. I don't think I've heard of that before. They must be very rare.
I guess it's sort of like a dust devil around
Picks up
fire.
some fire?
Yeah.
Okay.
And so
Like in the middle of a forest fire or something?
yeah, because fire also causes this wind, this hot air
Mhm.
rises, and all you need is a little wind around that rising air, and you'll
Got
have a fire hurricane, a
Would
fire
that-
tornado.
That'd be more like a tornado because there's
It's a
much
tornado,
smaller.
and there's also happens to be fire there, so it's a fire tornado
Got it.
or fire-nado.
We'll do two more questions here.
Yes.
Let's see. Gerard wants to know, do hurricanes happen more in the Pacific or the Atlantic?
Well, I actually don't know. I would assume it happens more in the Atlantic because that's more that we hear about more of them in the Atlantic because that impacts the East Coast of
Yeah.
the U.S. But we have a picture back a little bit ago that had pictures of hurricanes
Yeah.
off of Mexico and off of the U.S. and there it is.
And Gerard, if you wanted to go research this really quick in another tab, you could come back and let us know in the Q&A box and we'll share it with everybody.
Well, it looks like these hurricanes off the East Coast go a longer distance.
Yeah.
But
They seem to
and it looks like
dissipate
there's
sooner.
more of them too, but I
Yeah.
wouldn't swear to it.
Well, it does have a lot more history too. It goes back 100 years further in the Atlantic.
Yeah.
Anyway, Gerard, research it and let us know. Okay, we'll keep on going now.
Okay, so now we're going to go to the second class. Now, this isn't wind speed, the second class of tornadoes, and that's called a cone or wedge
Mhm.
tornado. And you can see why. It looks like a cone.
Yeah, it's
And this
wider
is-
than the rope tornado.
Right, this is bigger and stronger and wider.
Mhm.
And it's where the earth meets this spinning vortex or spinning part of the tornado that hits the
Mhm.
ground that can just wipe things out. It can wipe out anything that's in its path. Houses, trees, cows. See, I told you I saw
Yeah.
anything. And you're in a truck, don't feel safe because those swirling winds can pick up trucks and throw them around like they're rag dolls.
Because I think I heard once that tornadoes were so powerful, there are reports of them taking hay and throwing it so hard it embeds in like a tree trunk.
Right.
Just very quick, very
Right.
fast.
Yes. And so there is our wedge tornado. A wedge or cone tornadoes are usually more dangerous than rope tornadoes because, I mentioned it before, they're wider.
Mhm.
There's a larger area contacting the ground.
Mhm.
And there's another type of tornado we're going to look at. This is called the stovepipe. Now, in the old days, they used to have a stove
Mhm.
and this pipe going from the stove into the wall, going outside.
I'll see if I can find a picture of that really quick.
Okay.
I'll get that
So,
out of the way while you keep on
This,
talking.
and it's all, if you'll notice, this is all about the same size. Where it's hitting the ground and just before it goes into the cloud, it's all about the same size tornado. It's
Mhm.
not like the cone shape, or the wedge shape, which gets wider and wider,
Mhm.
but it's about the same, and so it's called a stovepipe.
All right, I'm finding a picture here just on Google Images. Okay, so this is a stove in somebody's house. Like people used to heat their houses with these. And I'm just gonna pull this on the screen here. Hope you guys can all see that.
Yeah.
But this is like down here, this is a stove. and there's just like a wide pipe going straight up out of the roof, and it comes out like looking like that.
Right, and it's about the same size all the way up. And so that's what that was great. Thank you, Marty.
So they say that it's kind of like the same width all the way up to the clouds.
Right, it's not like those other ones that we talked about.
Yeah.
Here's one. This is a wedge. Next one's a wedge tornado.
Okay. Well, we had. So this was a wedge. This is like a smaller wedge.
Yeah, that's a smaller wedge.
This is a bigger wedge. Wow.
Exactly.
That's really wide.
So these wide wedge tornadoes are the most destructive type because they have such a large area. It says the widest wedge tornado was over 2.5 miles wide at the base.
Wow.
Which means whatever it runs into, trees, farmhouses, electrical lines.
You have 2.5 miles of tornado to pass over before it's gone.
Right. That's a lot of tornado.
That actually goes into a question here from Amanda. Probably a good time to answer that question. She asks, can they make fires? Well, I bet a tornado going over some power lines or, I don't know, like a gas station or something.
Oh, what happens if it picks up a vehicle and smashes it down on, when it's full of gasoline or that can certainly explode. So yes, it absolutely can.
Definitely cause fires. Gerard asks, what is the most possible, I think he's asking, what is more destructive in Oregon, earthquake or hurricanes? I think if we look at that map again of where...
Oregon. In Oregon?
Yeah, in Oregon. He's asking, if we look at this map, I mean, I don't know that we've ever really had a hurricane.
We've never had a hurricane here in good old Oregon.
I'm going to guess earthquakes because we definitely do have earthquakes.
We have them. They're not particularly, well...
They're not super common like they are in California.
Right. Not like California or San Francisco.
But out of the two, I would say earthquakes are more common than hurricanes.
Absolutely.
I mean, if you look at the map, there's no hurricanes in Oregon.
No hurricanes here. But we do have earthquakes every now and then. I think I've been here 25 years. I've experienced 1 or 2 earthquakes.
Yeah.
1 or 2 earthquakes.
Yeah. Amanda asks, do we get these kinds of storms in Oregon? So we don't get hurricanes, but we do get the occasional tornado. Not very big, but...
Right. I've heard that. I know there was one in Salem, and I heard a couple of years ago there was one in Astoria.
There's one in McMinnville a few years ago.
Oh, that's right. That's right.
I think it tore like a little bit of roofing off of like one building.
Right. Yeah.
we don't get the kind that we're showing in the pictures.
It's
here.
not like the ones you see in Texas and Kansas, and they call it Tornado Alley. Because so many tornadoes are formed there because the warm weather coming up from the Gulf and the cold weather coming in, and it makes for big storms. Yeah. And then you get that swirling, and the swirling comes down to the ground.
Amanda asks, why would these be deadly? Well, a lot of very fast moving wind. I mean, normally the wind, we don't think much about it. It's like a windy day. But if the wind is strong enough, it can pick things up and move them. If you've ever tried to stand in a really strong wind, you know how hard it can be to stand there when you're getting something, the wind is pushing on you. But if it's strong enough, it could push a vehicle over that you're in and you could get hurt, or it could actually push your house over.
And it could rip the house to shreds. Yeah. And if those boards come flying at you, they could make a hole right into you, and that's probably not very comfortable.
For as long as people have been living in the middle part of the United States, they've been usually trying to dig what are called storm cellars underneath their homes, so that hopefully if a tornado comes through, it might rip the house off, but hopefully they'll be safe down in the basement.
If they're under the ground. Yeah. Under the ground. That's the best place to be in a tornado. They have tornado cellars. Yeah. A lot of parts of the country where they experience these tornadoes. They have tornado cellars, and there's a warning going on. They feel that they can sense a few minutes before an earthquake. Before a tornado happens, that there's a good chance a tornado is coming, and they send out an alarm, and people run out to their backyard and open their storm cellar door and go down and lock it and hope that the tornado doesn't land on top of them, because if it does, there's no saving them then. But it'll protect them quite a bit.
Two more quick little questions, and then we'll move on. I love your guys. They ask great questions.
They do.
Gerard researched it online, and he says that tornadoes and hurricanes, although rare in some places, have affected every state in the country. So maybe a hurricane touched Oregon, a little bit, a couple times.
Okay.
But probably not very much, I'm guessing.
I've never experienced a hurricane
Yeah.
in Oregon.
Might have been before our time.
Might have been.
Lastly, Paige wants to know which of these types of tornadoes we're showing is the most dangerous. So I'll bring those pictures up again.
Yeah. So
we showed the rope tornado.
that's remember, it's where it's hitting the ground is where it's creating the most damage. Now you could have rain, you could have hail from a tornado, from the clouds that are creating or spawning a tornado.
Mm-hmm.
But that's not doing the major damage. The major damage is the swirling wind that can swirl at hundreds of miles an hour,
mm-hmm.
and just pick things up, break it apart, and throw them.
Mm-hmm.
And so that's the most dangerous part. And the wider the tornado, the wider it is at the base. That's a small wedge. Wider than a rope.
Stovepipe.
That's about the same width, it looks like. There. That is a big, dangerous tornado. And I've mentioned they can be 2.5 miles wide.
Mm-hmm.
So let's see. If you could run for 10 minutes,
Mm-hmm.
10 to 15 minutes, that's about 2.5 miles. I'd say 15 minutes.
Mm-hmm.
If you could run for 15 minutes
In one direction.
in one direction, you're covering pretty good area. That's how wide this tornado is affecting. It's
Wow.
pulling up grass and trees and houses and barns and anything in its path, power lines, and just throwing it around.
And how long did you say? Amanda wants to know how long a tornado can last.
It could last just a few minutes. Did I write that down? I don't know that I wrote that down.
I mean, of course, they're all different lengths. A really small one.
Right, you could have
might
one that
appear,
lasts
disappear.
just for a few minutes.
Yeah.
You could have one that lasts for, I don't know, 10 minutes or so. I'm not from the middle of the country, so I don't know. I've never experienced a tornado.
Yeah.
But it can be just frightening. If you're in a house, it can rip the house to shreds and throw it around like.
I've heard that having a tornado anywhere nearby, anywhere in sight distance, it can be as loud as like a train going by.
Right.
Like a train continuously going by, if you've ever heard that.
Because
that's how loud these ripping winds
Because
are.
of the winds going hundreds of miles an hour and carrying things with it, and those things, whether it's pieces of houses or whatever, hitting other things, it can make very loud noises. And it sounds like you're very close to a loud train.
Mm-hmm. So here we have
multi-vortex and satellite tornadoes.
So what's a vortex?
A vortex is just spinning around.
Okay. And multi means more than one of.
Right.
So multi-vortex would just mean more than one spinning tornado.
Yes.
Okay.
Actually, here's some information that I got. You could have winds of 300 miles an hour in a tornado, and it could last for hours.
I just can't even think of a good analogy or comparison to try to. I'm just at a loss trying to think of anything that we've ever experienced in our normal lives that moves 300 miles per hour. I mean, maybe if you lived where like a bullet train was, like in some European or Asian countries, they have bullet trains that I think go that fast. But in our normal lives, nothing around us besides like planes in the sky.
Well, planes could go 500-600 miles an hour. So
they're all the way up there. I mean, we don't experience anything
Right.
on the ground that moves 300 miles per hour.
No, it's not the tornado that's moving 300 miles an hour.
Right.
It's the winds around
The
the
wind
tornado
inside of it.
that's spinning around.
Yeah.
That's 300 miles an hour. And
That
lasting
amount of
for an
destructive
hour-
force is.
For an hour?
Yeah.
Wow. That'll ruin your whole day.
Yeah.
Okay, multi-vortex means there's 2 or more tornadoes that are created around the main tornado. So it looks like that one on the left
mhm.
is the main tornado, and there's another one to the right, and there could be a few of them. multi-vortex, many of these spinning winds.
And satellite, of course, is something that kind of revolves around something else. Just like the moon is a satellite of Earth,
Right.
one of these tornadoes could be a satellite of the main tornado.
That's exactly right.
So this one on the right could be going around and around this bigger one.
Yes.
That'd be pretty wild to see in real life.
And sometimes they get pretty close to one another.
Mm-hmm.
But again, a tremendous, tremendous amount of damage.
Mm-hmm.
And now we're going to talk about water spouts. So when you have a tornado like that over water, it's called a water spout. And it says water spouts are technically tornadoes that occur over water. They develop when no thunderstorms are nearby. And so they don't count as an official tornado because there's not a thunderstorm.
Mm-hmm.
They're smaller and weaker than the powerful tornadoes in the Midwest. However, if you're in a boat and there's a water spout nearby, it can overturn your boat, create rough seas, and
so these guys are sailing in the right direction, is what you're saying.
they're getting the heck out of there.
If you're in a boat and you see a water spout, you should go in the opposite direction. Caleb wants to know, can tornadoes join together? Were you saying if that satellite tornado got close to the main tornado, they could just kind of join up into one bigger tornado?
Right.
Wow. Okay.
And tornadoes are very common in the southeast U.S. and in the plain states, like that area.
Wow. Is this what they call, I've heard of this term before, tornado alley?
Tornado alley. And it's usually, well, I've heard it about Texas and Oklahoma and Kansas, that whole area in red. That's where tornadoes happen because, as I said, you have moisture coming up and you have from the Gulf.
See, what you're saying is if you live in Arkansas here, you will have a tornado in your life at some point.
Yeah,
probably.
I think that's or you'll be able to see one.
Yeah.
It might not, run over your house, but you'll be able to. I'm sure you'll be able to see one.
Let's see. Gerard asks, what is the world's biggest tornado's name? Do they name individual tornadoes? I don't think they do, right?
I haven't heard them name tornadoes. I know they name hurricanes.
Yeah, so hurricanes, you might have like 10 in a year or something.
It averages a dozen.
Okay.
But you could have as many as 20.
So they usually name them like people names, like Hurricane Sandy, Hurricane Katrina, Hurricane, whatever. But tornadoes, I believe there's so many of them, and they're so usually they don't last very long. They don't name them.
They don't last as long as a hurricane, which can last for weeks and weeks.
It'd be like naming lightning. I mean, it can certainly be destructive, but it's usually over pretty quickly. So there's not really a point in naming them.
Yes. Now, when I was a boy, they used to name hurricanes only after girls, have female names for hurricanes. And then someone decided that was sexist. So now they have hurricanes named after men and after women.
And now there's more names too. They can go back. Don't they go back and forth, hurricane to hurricane? Yeah. So you get a lot more hurricane names that way.
Most common between March and early June, but tornadoes can form at any time of the year in any area. So it doesn't have to be in that area you just saw. It could happen anywhere, but that's a good chunk of the U.S.
So they're saying annual kilometers of path within 40 kilometers of a point. So these colors just mean like how close are you usually to a tornado. So yeah, we've had tornadoes here in Oregon, but it's pretty rare.
And I have a brother in Western Massachusetts, and he had a hurricane in his little town. But
if you live here like in Mississippi,
a tornado,
you are going to be like, all right, let's get ready for hurricane.
Here it comes
for tornado season.
Here it comes again. Well, the U.S. has more tornadoes than any other country.
Yeah.
Tornadoes are common in Australia, Europe, Africa, Asia, South America. New Zealand has about 20 tornadoes each year.
Wow.
And two of the highest concentrations of tornadoes outside the U.S. are in Argentina.
Down here in South America.
And Bangladesh.
Over here in Asia. Here? No,
I think it's
up here. Next to India.
Yes. Yeah. Bangladesh.
Wow, that's wild though. I mean, look how much of North America is tornado area.
Yeah, that whole thing.
It's much more than any of these other areas. If you lived in, say, Northern Africa, you probably never experienced a tornado almost, or Northern South America.
Well,
There's some
they
areas.
said it could happen anywhere.
This is not very common in those
Not
areas.
very common.
Okay.
Not very common.
Letica wants to know how they decide hurricane names. Well, I believe they go alphabetically.
Right.
And now they go back and forth from male to female names.
Right.
And honestly, there's probably just somebody whose job it is, and they just get a pick.
Right. So there's he probably has a list of names and said, no, this one was last year.
Yeah.
So we're not going to call it, but they go Abigail, Bob, Charlotte, Daniel, and they just go alphabetical. So if you know by the name of the tornado, how many tornadoes there have been? How many hurricanes there have been that season?
Okay, so like Hurricane Katrina, A, B, C, D, E, F, G, H, I, J, K. So that was like the 11th hurricane.
That was the 11th.
That year.
What about Hurricane Sandy?
Towards the end of the alphabet. T, U, V, W, X, Y, Z. So 7. So it's like the 18th?
Yeah, something like that.
The 18th hurricane that year?
Yeah, that was a big hurricane season.
I think if you go online and you Google this, I believe they publish ahead of time. They let you know, like, this is what we're naming all the hurricanes this year. We don't know if there will be this many, but you can just find the list. And if I was like a parent naming a baby, I might consult that list and say, we're not going to use the name of any major hurricane this year.
Why would that be,
Because
Corey?
I don't want to, maybe you don't want to name your kid after an incredibly destructive and deadly hurricane. That might not be good timing.
Right. Although kids can be
Destructive too.
extremely destructive, but not as destructive as a hurricane.
Wow. JJ says the most powerful hurricanes get their names retired. I could see that. Because after a hurricane is really famous, like Hurricane Katrina, they probably won't name a subsequent hurricane that, because it might be confusing for historians or people trying to, people trying to refer back to, hey, you remember Hurricane Katrina? People would have to be like, which one?
That was 2 years ago.
Yeah.
So same thing with Hurricane Sandy. That I think was the most destructive. That's the one with a 1,000-mile.
Yeah.
That's a big area.
Yeah.
Spinning around for 1,000 miles, rain and strong winds.
Mm-hmm.
And talk about strong winds. We're going to talk now about the enhanced Fujita scale.
Ah, somebody was talking about this.
Yes.
Briefly. Yeah.
That's the EF scale. And so it depends again on the speed of the wind gusts.
Yeah.
So there's a EF 0, that's the lowest. And that's 65 to 85 miles an hour. Now, 85 miles an hour is still pretty good for a hurricane, but not that much for a tornado. Tornadoes can get very, very strong winds.
Yeah.
Then there's an EF, enhanced Fujita 1, that's up to 110 miles an hour. And then the EF2, which goes to 135 miles an hour. The EF3 is 165 miles an hour. The 4 goes to 200 miles an hour.
Wow.
I mean, you can't hold on to a pole at 200 miles. It'll just blow you over and maybe blow the pole over too.
Yeah.
And then the most powerful, the EF5, produces gusts in excess of 200 miles an hour.
Wow.
They can sweep away bridges. Not a good idea to hide under a bridge because you and the bridge could be gone.
Mm-hmm.
They could knock down trees and tall buildings and anything else in its path.
Wow. Well, I hope you guys enjoyed learning about hurricanes and tornadoes today. I definitely learned a few things. Gerard says, why is it named Fujita? That's the name of the person who came up with the scale.
Developed the scale,
Yeah.
right.
Yeah. All right. Well, thank you guys all for being here today. I know there was a few questions that we didn't get a chance to answer, but Marty will be back next week for one last science class this summer. We have about a week and a half left of our summer session. So
That's right.
We'll have classes the rest of this week. We'll have classes Monday through Wednesday next week, and then we'll be off for a few weeks and then coming back in September. So
And where could people watch this in case they missed part of it, Corey?
we put a lot of videos up on YouTube afterward. Usually it's within a few days. So if you didn't see this class or a previous science class, check out YouTube and you can find them there.
So where they would look at YouTube Delphian School or Delphian
Yeah, just search
videos,
for, the emails that we send out every week have a link to the YouTube page. If you also just search Delphian School on YouTube, our page usually comes up as the first one, and we have playlists there of all of our videos. So,
oh, great.
Yeah.
Okay.
Well, thank you guys for coming. Oh, wrong one. Sorry. I'll bring up our ending thing here. Also, a lot of the information we talk about in science and whatnot is in our courses that we get from Heron Books. Like the Earth series talks about all sorts of awesome information about the planet. So you can always go and check out those books on heronbooks.com. There's that address one more time, heronbooks.com. All right, we will see you guys next week. See you then.
Thanks for joining us. And remember, stay curious.
Yes.